The topic is indefinite integrals 3, and in this particular chapter, there is a particular set of problems which involves linear and quadratic expressions. Linear, when I say linear expression, it means that the power of x is 1, and when I say quadratic expression, it means that the power of x, the maximum power of x is 2. Okay, so there are three category of problems that we need to focus on. The first category is, today we are doing this, integration of linear upon quadratic. Integration of linear upon quadratic. Okay. The second category is integration of linear upon root quadratic. Okay. And the third category is integration of linear into root quadratic. Linear into root quadratic. Okay. So these three categories we have to prepare well. Fine. So let us take some examples of each category of problems. Fine. So just a second, I'll just pull out some problems. Yeah. So today, yes, we are working on the first category, that is linear upon quadratic. So today we'll be specific to this particular category problems, linear upon quadratic. Okay. Yeah. So the question is integration of phi x minus 2 upon 1 plus 2x plus 3x squared dx. So first I'm going to rearrange this, write in a specific order. Okay, always the greater power comes first. So 5x minus 2 upon 3x square plus 2x plus 1 dx. Fine. So the maximum degree of x in the numerator is 1. The maximum degree of x in the numerator is 1. And the maximum degree of x in the denominator is 2. So the numerator term is linear, but then the denominator term is quadratic. So this is linear upon quadratic category. Okay, so if you have understood the starting point, just mention it over the chat that it's fine that you are understanding. So this is linear upon quadratic. Fine. So whenever it is linear upon quadratic, what we will do is we'll write a fixed statement. Fixed statement. Okay. So numerator or linear is equal to a dy dx of quadratic term plus b. The numbering of the equations is very important. Huh? This is equation number 1. The question in a proper format, this has to be equation number 1. Okay. And then this is the next step. Linear is equal to a into dy dx of quadratic plus b. So the linear term is 5x minus 2 a into dy dx of quadratic. The quadratic term is 3x square plus 2x plus 1 plus b. So this will be 5x minus 2 a into 6x plus 2 plus b. Now immediately after the derivative, once you derivate this, immediately after the derivative, whatever step you get, that is equation number 2. That is equation number 2. Okay. So after marking this equation number 2, you can open the bracket on the right hand side. 6ax plus 2a plus b. A into 6x is 6ax, a into 2 is 2a. Okay. Now underline the x terms in the left hand side and in the right hand side. So these are x terms. So by comparing the x terms, can I say phi is equal to 6a? If we compare the x terms, equated the left hand side term and the right hand side term. Okay, so this is by comparing. So next step I would write by comparing the coefficients of the x terms, or you can simply write by comparing. Fine. 5 is equal to 6a. So a is equal to 5 by 6. A is equal to 5 by 6. Okay. Now compare the non-x terms. Look at the non-x terms. Minus 2 and plus 2a plus b. That is 2a plus b. So compare the non-x terms. Minus 2 is equal to 2a plus b. Minus 2 is equal to 2a plus b. So minus 2 is 2 into 5 by 6 plus b. Okay. The value of a is 5 by 6. So we'll make use of that. So minus 2 is equal to 5 by 3. 2 ones are 2. 3s are. Okay. And b is equal to minus 2 minus 5 by 3. So minus 2 minus 5 by 3 is nothing but minus 6 minus 5. That is minus 11 by 3. Okay. We got the value of b. Now put the value of a and b in equation number 2. Put the value of a and b in equation number 2. So I'll show you equation number 2 first. See, equation number 2. So here you have to put the value of a and b, right? So I'll write put a b in equation number 2. So 5x minus 2 is equal to a. A is 5 by 6. A is 5 by 6. Okay. 5 by 6 into 5 by 6 into 6x plus 2 plus b. B is minus 11 by 3. So I'm putting the values of a and b in equation number 2. Okay. Now don't simplify this right hand side. Don't simplify. If you simplify the right hand side, you will get 5x minus 2. The purpose is not simplification. Okay. Now go to equation number 1 and just write from 1. Okay. This is equation number 1. We got the value of 5x minus 2. What is the value of 5x minus 2? The value of 5x minus 2 is this. So just replace the value of 5x minus 2. 5 by 6, 6x plus 2 minus 11 by 3 upon 3x square plus 2x plus 1. Okay. So I replace the value of 5x minus 2 by this in equation number 1. Now I will split this into two parts. Okay. So this will be integration of 5 by 6, 6x plus 2 upon 3x square plus 2x plus 1. 5 by 6, 6x plus 2, 3x square plus 2x plus 1 dx, or dx we'll just write later on, minus 11 by 3 upon this entire thing. 11 by 3 upon 3x square plus 2x plus 1 dx. Now individual integration, take 5 by 6 outside, 6x plus 2, 3x square plus 2x plus 1 dx. So this is f dash x upon f of x. Derivative of the function upon the function itself. Minus 11 by 3 integration of 1 upon 3x square plus 2x plus 1. Okay. I hope you are aware of this property, f dash x upon f of x. The derivative of the denominator is the numerator. Okay, so f dash x upon f of x is log modulus f of x. Okay, minus 11 by 3. Now this part, I'm writing it as I1. Okay, I'm writing it as I1 because I'll solve it separately, this part. Hence, I'm writing it as I1. Okay, so f of x, what is f of x? 3x square plus 2x plus 1. So I is equal to 5 by 6 log mod 3x square plus 2x plus 1 minus 11 by 3 I1. Equation number, the next equation, this is, I guess this is equation number, let's say 3. Okay, yeah. So I'll park this over here itself. I'll solve I1. Now I1 is, what is I1? 1 upon 3x square plus 2x plus 1 dx. Integration of 1 upon 3x square plus 2x plus 1 dx. Now we have a middle term, completing squares with a middle term. So whenever there is a middle term, there shouldn't be any coefficient of x square. So the coefficient of x square 3 has to be eliminated. So 3 x square plus 2 by 3x plus 1 by 3 dx. Okay. 2 does not have 3 along with it. So I'm writing 2 by 3. 1 does not have 3 along with it. So I'm writing 1 by 3. Okay. So this will be half into coefficient of x the whole square. So half into 2 by 3 the whole square. The coefficient of x is 2 by 3. So this is 1 by 3 the whole square. Okay. So I'm going to add 1 by 3 the whole square and subtract 1 by 3 the whole square before the last term and after the last term. Okay. So I1, this is I1, right? So I'll take 1 by 3 common. I1, 1 by 3 outside. Okay. So it will be x square plus 2 by 3 x plus 1 by 3 the whole square. X square plus 2 by 3 x plus 1 by 3 the whole square plus 1 by 3 minus 1 by 3 the whole square. Okay. Completing squares. Before the last term, after the last term. Before the last term you added, after the last term you subtracted. Okay. First 3 terms and last 2 terms. 1 by 3, 1 upon x plus 1 by 3 the whole square Okay. Last two terms we'll just solve. 1 by 3 minus 1 by 9. 1 by 3 the whole square is 1 by 9. So multiply and divide by 3 will take LCM. So this is 2 by 9. So this is plus 2 by 9. Okay. Now this part you're well aware of. So this is equal to 1 by 3, 1 upon x plus 1 the whole square, root 2 by 3 the whole square. So this is x and this is a. 1 upon x square plus a square. So 1 upon x square plus a square is 1 upon a tan inverse x upon a. 1 upon a tan inverse x upon a. So I'll just write the next step. This is 1 by 3, 1 upon a tan inverse x by a plus c1. I'm writing c1 because this is I1. So a is, I'll show you what is a. A is root 2 by 3. So 3 will get cancelled. Tan inverse of x. What is x? X plus 1 by 3 upon root 2 by 3. Fine. So this will be 1 by root 2 tan inverse 3x plus 1 upon 3. Take LCM over here upon root 2 by 3 plus c1. This 3 and this 3 will get cancelled. So what you are left with is 1 by root 2 tan inverse 3x plus 1 upon root 2 plus c1. Now this is I1, right? So we are going to put this value of I1 in equation number 3. Okay, I'll show you equation number 3 now. This is equation number 3. See, right there in front of you. Equation number 3. So just replace the value of I1. So I'll write from 1, last step, I is equal to 5 by 6 log mod 3x square plus 2x plus 1 minus 11 by 3 into I1. Now the answer of I1 we got 1 by root 2 tan inverse 3x plus 1 upon root 2. 1 by root 2 tan inverse of 3x plus 1 upon root 2. Fine. Okay. So this will be written as plus c. Because it is I will have plus c. If it is I1, write c1. Okay. Now the last step, 5 by 6 log mod 3x square plus 2x plus 1 minus 11 upon 3 root 2 tan inverse 3x plus 1 upon root 2 plus c. This is the end of the problem. Okay. Any feedback? Have you understood this? Yes or no? Okay. So one more problem of this category I'll take, but then it will be a bit more complicated one. I'm erasing this. Fine. So the question is integration of 3 sine theta minus 2 into cos theta d theta phi minus cos square theta minus 4 sine theta. Okay. Now see, initially the problem will be difficult. Later on, you'll have to solve once the initial part is clear. Now, one observation over here. Derivative of sine is cos, and that cos is present in the numerator. Okay. Derivative of sine is cos, and that cos is present in the numerator. But then we have to eliminate this cos square. So step number 1 is I'll just write this cos square as 1 minus sine square theta using fundamental identity. Okay. So phi minus 1 minus sine square theta minus 4 sine theta. This is equal to I. We'll just simplify the denominator. 3 sine theta minus 2 cos theta d theta upon phi minus 1 is 4 plus sine square theta minus 4 sine theta. Okay, I just open this bracket. Phi minus 1 became 4, minus minus is plus, sine square theta is sine square theta minus 4 sine theta. Now again I am observing the derivative of sine theta is cos, and that cos is present. Okay, so step number 1 was to eliminate this cos square and make it 1 minus sine square. Okay, now we are having only sine and cos terms. Cos term is single over here. So derivative of all these sine terms is cos. So again, I'm going to rearrange this to make it more specific. I is equal to 3 sine theta minus 2 into cos theta d theta upon sine square theta minus 4 sine theta sine square theta minus 4 sine theta plus 4. Okay, something like this. Minus 4 sine theta plus 4, sorry. Okay. Now what you can do is you put sine theta as t. This is method of substitution. Now the only reason why we are putting sine theta as t is because the derivative of all sines, individual sines, is cos, and that cos is present in the numerator. Okay. So d by d theta of sine theta, whenever we do method of substitution, we derive it with respect to the left hand side variable. Left hand side variable is theta. So derivative of sine theta is cos theta dt by d theta. Now look at the integration term which is written over here. Look at this term and tell me which terms to group. From this, which terms to group? So the answer is we can group cos theta d theta. We'll take it together. Cos theta d theta, which is equal to dt. Cos theta d theta is equal to dt. Fine. So I integration 3t minus 2. See, just remember sine theta is t. Sine theta is t. So the numerator will be 3t minus 2. Okay. Cos theta d theta. Cos theta d theta will be dt. So 3t minus 2 into dt upon t square. Sine theta is t, so this will be t square minus 4t plus 4. T square minus 4t plus 4. Right? So now don't you feel the numerator term is linear and the denominator term is quadratic? The numerator term is in terms of t and the maximum power of t is 1. The denominator is a quadratic term and the maximum power is 2 over there. Fine. So it's linear upon quadratic. So mark this as equation number 1. So if it is linear upon quadratic, what is the first step? First step is linear is equal to a dy dx, but then I'll write dy dt. A dy dx of a by dt dy dt of quadratic plus b. Okay. Now what is the linear term? The linear term is 3t minus 2. 3t minus 2 equal to a into dy dt of quadratic. The quadratic term is t square minus 4t plus 4. Okay. Plus b. Equation number 2. Sorry, this is not equation number 2. After the derivative, whatever we get, that will be equation number 2. So 3t minus 2 a into 2t minus 4 plus b. This will be equation number 2. This will be equation number 2. So 3t minus 2, 2at minus 4a plus b. Multiply a with both the terms over here. Now I will compare the t terms and non-t terms. So by comparing the t terms, the coefficient of t is 3 and the coefficient of t is 2a. So 3 is equal to 2a. This gives me a is equal to 3 by 2. A equal to 3 by 2. Okay, and now the non-t terms. The non-t terms are minus 2 and minus 4a plus b. So minus 2 is equal to minus 4a plus b. Equate the non-t terms. So minus 2 is equal to minus 2 into 3 by 2 plus b. Okay. 2 ones are 2 twos are. So this will be minus 6. That will be 6 minus 2, which is equal to 4. So the value of b is 4. By solving, I got the value of b as 4. Okay. A is 3 by 2 and b is 4. Now put the value of a and b in equation number 2. So see, this problem is also linear upon quadratic, but then initially we used method of substitution. Okay. So put a and b into equation number 2. So 3t minus 2 is equal to 3 by t, 3 by 2, 2t minus b. And b is 4. 3t minus 2, a is 3 by 2 into 2t minus 4 plus b. Okay. What is b? B is 4. So plus 4. Now don't simplify this, otherwise you'll get back to this 3t minus 2. So don't simplify. So from 1 integration of, we got the value of 3t minus 2. I'll show you equation number 1. Okay. So equation number 1 is over here. So 3t minus 2 value we got. What is the value of 3t minus 2? 3 by 2 2t minus 4 plus 4 upon, this is dt, right? Plus 4 upon t square minus 4 plus minus 40 plus 4. T square minus 40 plus 4, right? So now just simplify this further. Split this into two parts. I is equal to 3 by 2, 2t minus 4 upon t square minus 40 plus 4 plus 4 upon t square minus 40 plus 4 dt. Now individual integration by taking the constants outside. 3t by 2, 2t minus 4, t square minus 40 plus 4 dt. 4 outside, 1 upon t square minus 40 plus 4 dt, right? So this is f dash t upon f of t. F dash t upon f of t is log modulus f of t plus 4 into 1 upon, you can take this I1 and solve. Okay, so better I'll take this I1 to avoid confusion. Only this part, don't take 4 along with it, is I1 and this is I. Okay, so in the next step, I'll just put the value of f of t. So I is equal to 3 by 2 log mod f of t. What is f of t? T square minus 40 plus 4. T square minus 40 plus 4. Okay, plus 4i1. Equation number 3. Now I'll solve this I1 separately. 1 upon t square minus 40 plus 4 dt. Okay, now we have a quadratic with a middle term and constant up in the numerator. You can use half into coefficient of x. So half into coefficient of x, x is t. So this will be 2 square. So before the constant and after the constant, or before the last term and after the last term, just put that 2 square. So t square minus 40 plus 2 square plus 4 minus 2 square. Now this will get cancelled. So the first three terms are t minus 2 the whole square. Last two terms ka there is no answer because everything gets cancelled out. So the first three terms are t minus 2 the whole square. So I1 1 upon t minus 2 the whole square dt. So t minus 2 raised to minus 2 dt. T minus 2 raised to minus 2 dt. X raised to n. So x raised to n plus 1 upon n plus 1. So this is t and this is n. So dy dt of t minus 2 will also come plus c1. Okay, because of the chain rule, and the derivative part comes in the denominator for the integration thing. So this will be t minus 2 raised to minus 1 upon minus 1. Okay, I1 is equal to t minus 2 raised to minus 1 into 1. Why minus 1 into 1? This is minus 1 and derivative of t minus 2 with respect to t is 1. 1 minus 0. Okay, so this will be t minus 2 raised to minus 1 upon minus 1 plus c1. Take this minus sign up in the numerator. This minus sign. So minus t minus 2 raised to minus 1 plus c1, which is equal to minus 1 upon t minus 2 raised to 1 plus c1 indices. But then what is t? In the entire problem, we had taken sine theta as t. So this will be sine theta minus 2 plus c1. Okay. Now put the value of I1 in equation number 3. So I'll write from 3, okay. I'll show you equation number 3. Yeah. So 3 by 2 log mod t square minus 4t plus 4 minus, sorry, plus 4 I1 plus 4 I1, and the answer for I1 is minus 1 upon sine theta minus 2 plus c. Since it is I, hence I'm writing plus c. So 3 by 2 log mod t is sine theta, okay. And the last step, you can just write the sine theta the whole square as sine square theta. So that is the end of session number 1 of linear quadratic problems. And the first session was based on linear upon quadratic. So there are 2 more sessions, linear upon root quadratic and linear into root quadratic. Okay, that will cover up. Thank you.